Right, this is question 6, a question on vector. You are given vector A and vector B and asked to find the modulus of A. Alright, to do so, we use the square roots of the sum of square of the ijk component of the vector A. So square, 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 and find the sum. The answer is square root of 21. Now we move on to part 2. You ask to find A dot B. Right, and this is again not difficult. What you need to do is to find the products of the I component of the two vector and then the products of the j component of the two vector, followed by the products of the k component of the two vector, and then sum them up. And the answer is 7. We move on to part 3, and here you ask to verify this statement. Alright, to do so, we start with the left hand side. A plus B. Alright, to find A plus B, we must know what is the vector A and B, and these are given in first part of the questions. So the sum is equal to 6, -1, -6. Right, here we need to use another important property of vector. That is, a vector dot itself is always equal to the square of the modulus of the vector. So over here, we have the square of the modulus of the vector, and it must be equal to the vector dot the vector. So in this case, 36, 1, 36, and the sum is 73. So we have done for the left hand side. Now we move on to the right hand side. To do so, we're going to use a similar concept to find the square of the modulus of A, or this is already obtained from part A, and we're going to use a similar concept to find the square of the modulus of B. Alright, and it's equal to B dot B. Alright, 25, 9, 4, and then add them up, equal to 36. And finally, we find A dot B, and again, this is known from the second part of the questions. Alright, we have already obtained that it is equal to 7. So now we have the modulus of A and modulus of B, and we also know A dot B. So we just add them and subtract 2 times A dot B, and the result is 73. So the left hand side is 73 and the right hand side is 73. Hence, the statement is valid. Move on to part B of the questions. Alright, you have to use the vector property here to prove this statement. Okay, so we know that the square of the modulus of the vector is always equal to the vector dot the vector. And this gives us c square. Alright, and then CD, DC, and then D square. Now we know that C dot C is also equal to square of the modulus of C. D dot D is equal to the square of the modulus of D. And CD and DC are equal. So we have 2CD. Hence, we prove the statement. Okay, we move on to part C. right? Now, over here you are given that the modulus of C is 10, modulus of D is 5, and C dot D is 25. So what we need is to substitute all this value into the equations, right, into this equation here, and we obtain the square of the modulus of C plus D is equal to 175, and hence the modulus of C plus D is square root of 175. Now we can actually make use of similar concept that we find these expressions, right, to find the square of the modulus of C minus D, and it have to be equal to C minus D dot C minus D, and we obtain the result here, and C dot C is the square of the modulus of C, D dot D equal to D square of the modulus of D, and CD equal to DC, hence we have minus 2CD, and we substitute the value of 10, 5, and 25 into these expressions, we obtain 75. Hence, the modulus of C minus D is equal to square root of 75.